Hello everyone, my name is Naël, I'm a computational journalist and the creator of Code Like a Journalist, a free, online, open source course about data analysis and data visualization with TypeScript. I'm quite excited about this video because it's our first project. I think we now have enough TypeScript knowledge to actually build something, and this project today is a savings account calculator. The idea is to have random interest rates that are applied over a number of years with an initial amount of money. Sometimes our calculations will show gains, sometimes they will show losses, and our code will do all of these calculations for us based on specific parameters that we are going to code. As usual, if you want to know when new lessons are available, subscribe to the newsletter, add a star to the GitHub repository, or subscribe to this YouTube channel. So let's go. I have VS Code open on the side. Let's get started. So when we code something, I think it's very important to start with a question. If you are a journalist, that's your bread and butter, questions. And I think in other data fields, it can help a lot as well to have one clear question that we start with, just to make sure that we're not going into too many directions at once. So our goal today is to answer this question: how much could I make by putting my money in a savings account? To answer this question, we will need to calculate the difference between the initial amount and the final balance in the account, right? Either you made money or you lost money. Also, to answer this question, there's a few factors that can change the result. Of course, the initial amount of money, of course, the interest rate of the account, the fluctuation of the interest rate. So in this project, to make things a little bit more interesting, we are going to randomize the interest rate every year. And of course, the number of years the money will stay in the account. So with this question and this indicator and these parameters, we have a pretty good idea of where we're going and what we need to take into account. Something that we're going to do in this project to simplify our lives is to work with annual rates. So we will update the account balance just once a year. All right, so we can start. As usual, we're going to open a new folder. Here we go. Let's create a main.ts, a dino.json file, and we can start with a console log hello. And we can run this with dino run watch check main.ts. Let's go. So the number of years. So if the money stays in the account for 10 years, it means that we need to update the balance 10 times, once every year, as we said at the beginning. And this is a perfect job for a loop. So we can start by iterating over the years. We can create a variable years and just loop over the years this way. So let's do it. You can start with a constant years. The user will be able to change this very easily. You want 10 years, you put 10 years. You want 50, you put 50. It's always great to use variables for this kind of parameters. Then we want to iterate through the years. So we can use a for loop, and we can say, hey, let's create a new variable year. Let's start with saying that it equals 0. And we want our year to be smaller than our years here, the variable that is over there. And every year, we want year to increment by 1. And for now, we can just console log our year. So here we go, we have the result over there. By the way, this is a new syntax that I'm showing you right now. This here is a shortcut to create an object directly. So when you have curly brackets like this, and you use a variable between the curly brackets, it will create a new object with a key that will be the name of your variable and the value which will be the variable value. So here I'm saying, hey, in this loop, create a new object with a key year, and the value should be the actual year. And this is what you're seeing below. So on the first iteration, the year is 0, 1, 2, 3 until 9. So we have 10 years. So our loop is working. But this is not very convenient, obviously. We would like to have actual years that will be more easier to understand. So let's remove years here and, not remove it. Let's add another variable that would be start year, starting year. And let's say that we start in 2025. So we can update our loop now by saying, hey, I want the year in the loop to start with the starting year. So now this here means that the first year will be 2025. For the condition to stop the loop, well, we want the year to be smaller than the starting year plus the number of years that we want to iterate on. Let me make this disappear so it will be easier to read, right? And for the incrementation, we can keep it like this. We want year to increment every year. So year will start on the first iteration at 2025, second iteration 2026, etc., until 2035, because we want this to stop when starting year plus years is reached. And now you can see that we have our 10 years, and it's easier to understand instead of having something like 0, 1, 2, 3 until 9. So that's great. Maybe we can rework this a little bit to store, to create a variable result in which we will put the results. So results will be an array where every year we're going to put the result of our calculations in it. And so now, instead of console log year, we can use the push method. Like this. And we can log results at the end. Here we go. So now we have an array of objects with the year. Actually, we can use console table. So everything now will be shown as a nice table. So this is a basic setup that I use very often. You create an array to store your results. You do your calculations very often with a loop, and then you log the results as a table. The push method is available with arrays. It pushes whatever you want at the end of the array. So on iteration 1, there is nothing. So the year 2025 is pushed at the first index, at index 0. But then on the second iteration, the year 2026 is pushed is inserted at the index 1, etc., etc. This is why we have our years in the proper order with the index showing here on the side. Now we can start working on the interest rate and the balance. So something we can do is to use variables again for the initial amount of money. So here I'm putting $5,000. We can also set an interest rate of, let's say, 2. And we can create a let variable for the balance. We're using a let variable for the balance because we are going to overwrite the balance every year, right? We're going to update the balance. So you cannot use const, you need to use let to overwrite a variable. And at the beginning, the balance equals the initial amount. And so now, in our loop, we can start calculating the gains or the losses. So in our loop, at each iteration, what we want to do is calculate the gains or losses. The calculation is pretty simple. It's the amount of money that you have in your account multiplied by your interest rate. It's a percentage, so we need to divide it by 100. So this is how we calculate the gains or losses every year. Now, if you gained money or if you lost money, it will show in your balance, right? So we need to update your balance. Oh, plus equal. This here is another way of writing things a little bit shorter. So this is the same as this. So here we are overriding balance by itself plus the gains or the losses. But a way to avoid repetition is just to do this. So this means, hey, overwrite balance with itself plus this. Now, if our interest rate is positive, you will gain money, so your balance will increase. And actually, we can put that right now, gain or losses and balance. Right, so you can see that with a 2% interest rate, the gain or losses on the first year, it's for $5,000, it's $100. So your balance increases to $5,100. Then you can see the compounding interest starting to appear. So you have $5,100 as a balance. So the next year, you earn a little bit more than 100, etc., etc., etc. It increases over time, and you can see the effects of compounding interest. This is with a positive interest rate. But if we do -2, you'll see that you'll start losing money. Every year, you'll start money. At first, you have $5,000. You will lose $100, and that's your balance. Then you're losing 2% again, 2% again, 2% again. This is why this technique works well. If the interest rate is positive, it will be positive, it will be a gain. If the interest rate is negative, this number will be negative. So when you add a negative number, you actually subtract. And so your balance every year will be updated. Yeah, we pushed in our object every year, we push the gains or losses and the balance. This is very convenient. You have a table that shows you everything this way. One note, yeah, this is quite important. One thing to notice here, gains or losses is scoped inside the loop. When you create curly brackets like this, and when you create new variables inside curly brackets, you are creating variables that exist just in the curly bracket. So gain or losses, for example, if I try to log it here, I will have an error. Cannot find name, gains, or losses. Maybe you're wondering, but why? It's just over here. Yes, but because you have curly brackets, you have a block of code. And variables that are created inside a variable, inside a block of code, exist just inside this block of code. So what your computer is doing here, it's creating all of these variables, they are available in its memory, then it goes inside these curly brackets. In there, you have a different scope. Everything that is outside of the scope is available in it, but anything that is created in the scope will disappear as soon as the loop is done. So gain or losses is created on each iteration, and at the end, since we have this closing curly brackets, gain or losses is not in memory anymore. This is how JavaScript manages TypeScript and JavaScript manages its memory. Just something to know. And actually, it's a great feature because if you try to use gains or losses outside of the loop, you can have unexpected results and bugs. So it's better to not be able to use it at all. Let's bring it to again. So by default, our computer is not rounding values. You can see it here. We have a lot of decimal places. We can round it, ask our computer to round it. There's something called math, which is an object that is always available, and math has a lot of methods to do mathematical calculations, and one of the methods available is round. So we are going to use that, and we are going to wrap our calculation for the gains or losses inside round brackets. And so now gains or losses is rounded to the closest integer, and you can see now everything is easier to read in our table. So this is going pretty well. We already have a saving account with an interest rate that stays the same over time, and we can see the effect of compounding interests. Now, we can randomize the interest rate to make things a little bit more interesting. We can use math random. So here we used math round to round this here, the gains or losses, but there's something else that exists, and it's math random like this, no parameters between the brackets. If you log this, you'll see that we have a random value that is being created by your computer on each iteration. They are always different. Math random returns a value between 0 and 1. That's what it does. If you save multiple times, you'll see that the values are always changing, and you have different values than I have. This is random. It's not truly random. You should not use math random for security purposes. It's not cryptographically secure, but in our case, that's enough. Also, you have different random distributions algorithms. Here, it's a uniform distribution, which means that you have the same chance of getting any number between 0 and 1. I'm just going to comment the table for now to make things a little bit easier. So if we want to randomize our interest rate, what we want to do is sometimes we want an interest rate that is negative. Sometimes we want an interest rate that is positive. Right now, our math random function is just returning numbers between 0 and 1. It would be great to have some numbers negative and some numbers positive. Since it's always between 0 and 1, we can do something like this, minus 0.5. And now you can see that we will have values between minus 0.5 and negative 0.5 and positive negative 0.5 and positive 0.5. We have a range of values that is smaller than 0 and greater than 0. And so now it's actually quite simple. We can multiply this number by a range to make a randomized interest rate. So for example, if we create a new variable, const interest rate range, and set it to 20, and we multiply this by our interest range, you can see that now every time we save, we have values that are between -10 and +10. The range is 20, but we have positive values and negative values within that range. And now it's pretty straightforward. We can apply that to our to our interest rate before calculating the gains or losses. So we can create our random number. I'm just following the example on the lesson and trying to keep things the same way. So if you want to reread a section, you won't be too confused. So here we are creating a random number between negative 0.5, positive 0.5. Then we can create a random fluctuation. This is a very fancy name for a variable. And this will be the random number multiplied by the interest range. So now this here, the result of this with this value is something between -10 and +10. We can log it again, even if it's the same result as before. Here we go. So it's between -10 and +10. And so now we can create a random interest rate. Random interest rate. That is our interest rate plus the random fluctuation. Right? And so if we log this, you can see that we have a random interest rate. Since we have an interest rate of 2, the values will be between -8 and +12, right? And this is great because you can play with this. You can have a different interest rate with different ranges. And if you start with 2 and a range of 20, it means that most of the time you will have positive random interest rates. If we do -2, it means that most of the time we will have negative interest rates with this random fluctuation because the random distribution is uniform. And so now what we can do, actually we can round the random interest rate to make things a little bit easier. There we go. Math random, not random, round. Right, you can see that our interest rates rounded. And so now what we can do is just replace our interest rate for the gains or losses calculation with our random interest rate. And we can log the results, and we can also add our interest rate to our object. So we will see it in the table. So here I'm not using the shortcut. I don't want to have the table with random interest rate in there. I just want interest rate. So I use the traditional syntax for object, which is the key and the value. So you can see that we have year interest rate, gains or losses, and balance at the end. And so what we're doing now, every year, all of this is happening within the loop. So every year we have a new random interest rate, this will give us different gains or losses, and our balance will be updated. So if you save again and again and again, you'll see that the interest rates are different, so the gains and losses are different, and so the balance, especially on the last year, will vary a lot. Sometimes you're lucky, sometimes you're not. And all of this can be updated because we have variables at the top. So it's very easy to change that and to run another simulation with 10,000, an interest rate of 0.5, an interest range of 25 or just 5, and different starting years and many, many years if you want to. It's a nice little algorithm. So this is the last step. We want to answer our question. To answer our question, we can extract the last result. So we have our table here, but actually it would be great to have just this value here, the balance at the end, because we need to compare the initial amount with the final balance to check if at the end you made money or you lost money. So to extract the last element of the results array, we can create a new variable, last result, and we grab the result, and we want the object in the last position. To retrieve the element of an array, we can use the index. So for example, if I do this here, and let's hit the table for now. So if I grab results with the index 0, I'm grabbing the first year, right? I want to grab the last year, but it won't always be the same because the number of years will change. So something that you can do, and that you will very often see on code examples all over the web, is to use the results, the array length. So here what we are saying is grab the results array and give me the element at the index matching the results length. Length is the number of items in it. If you do this, you'll have something undefined, right? Because if you have 10 years, the results length will be 10. But indexes always start at 0 in JavaScript. So what you need to do is -1. And now you have the last year, right? There's 10 elements in the array, but the last element index is 9 because indexes start at 0. So you do the length -1. You'll see that a lot all over code examples. Might look a little bit weird at first, but you'll just get used to it. And so now we have the last result. That's our last year, the object with the values for our last year. We can extract the final gains or losses by using the balance here. So last result. Since everything is typed, you have, when you do the dot after the variable, you have directly access to all of the keys, which is very nice, and it will avoid you a lot of typos. So what we want is the balance, but the final gains or losses are the last result balance minus our initial amount. And so now if we log the final gains or losses, we can uncomment our console table just to make sure. So you can see here, for example, so the balance, the final balance is $5,705. The initial amount was $5,000. So yeah, it works. The final gains or losses is $705. Now we can do a nice sentence to answer the question that we had at the beginning. And to do that, we can use conditions. Because if the final gains or losses are greater than 0, it means that congratulations, you've made money, right? If it's not the case, if final gains or losses is less than 0, it means that, sorry, oops, you've lost money. And the last possibility, so if it's not greater than 0, if it's not smaller than 0, it means that it's equal to 0. So we can have a last message saying, you've neither lost nor gained money. Here we go. And we don't need to log this, and we can put the table maybe after this, so it will be easier to read. We have the result being displayed here. Something that I like to do is to add extra lines in the terminal when I'm logging important messages, and you can do that with the \n. This means new line. For example, here you see I've added a new line before congratulations, so we have an extra line here. So we can do the same thing at the end. One nice little trick about VS Code: if you need to put the same thing in different places, you can use multiple cursors at the same time. So if you press Alt and click everywhere you want to add an extra line, you'll see that you will have multiple cursors. And so now you can write, you can modify your code directly at all of these places at once. So here I'm doing a \n. Here we go. And if you do escape, you go back to just one cursor. And so yeah, it works. So we have conditions. Congratulations, you've made money. Let's try a few times. I'm sure we're going to lose money at some point. Maybe I can change the interest rate to 0, so we'll have the same chance of losing or winning money. And sorry, you've lost money. So our condition is working right now. You can see that it's less than $5,000. Cool, so we are answering the question. But it would be great to add a little bit more information, to add maybe the percentage gained or the percentage lost. So to calculate the percentage, it's fairly easy now. It's the final gains or losses divided by the initial amount. We can log it just to have a look. Here we go. So here we lost money. Oh, we got more money than the initial amount, and it's an increase of 7%. We can multiply this by 100 to make it in percentage. Here we go. So here we lost money. We lost 4% of the initial amount. It works. We can maybe round this. Here we go. Wrong line. Here we go. So we can wrap this calculation inside the round to have a rounded percentage. And now in our message, we can tweak things here. So maybe we can use backticks now instead of quotes to have a multi-line string that will be logged. So for example, if the final gain or losses are greater than 0, we can write something like congratulations, you've made money, and the initial amount was $, initial amount. So you you are probably wondering what this is. When you're using backticks, you can inject variables inside your text. So here I'm saying, hey, I want to inject initial amount right here. To do that, you use the $ followed by curly brackets. And this here will be the value of the initial amount. Here it's a little bit weird because we have two $, but basically the first one is just the text, a string. The second one here is telling Dino, I want to inject a variable in there. You'll see the result in a minute. After that, you have the final amount. Oops. We have the final amount, which is the last result balance. We have the gains, because your final gains or losses are greater than 0. And here we can add the percentage. So the percentage will be positive, so we can add a plus sign, percentage, and with the percentage sign. Let's see. Okay, so I saved a few times, so we'll have to have the some gains. And you see that now we have a multi-line string that is being logged, which is nice. You've made money, you have the initial amount. This is injected directly in the string from the variable initial amount. The final amount, which is injected from the last result object, and we select just the value of the key balance, and then the gains here injected into the string, and the percentage injected between parentheses. This is very nice. We can do the same thing for the losses. Sorry, you've lost money. Initial amount. And we can do the same thing. Actually, we can just copy and paste this. Except that here the percentage will be negative, right? So sorry, you've lost money, initial amount, last result. So let's save a few times and to get, oh, you've lost money. Oh yeah, there's already a minus sign, so we don't need one here. Okay, it works. And finally, there's no finally, that's the end. I think we've made everything we wanted. It's working pretty well. This here, the backticks with the injected variables, this is called template literals. They are used very, very, very often because they are very convenient, right? You can create initial amounts at the beginning of your script, for example, and you know that this is the value that will be reused directly in your string over there, and the value that will be used in your code as well. So they are very convenient and they are widely used. And that's the end of the project. We have a savings account calculator with a random interest rate, and we are logging the result with template literals and displaying the detailed result year over year in a nice, good-looking table. So congratulations, you've done a lot in this project. Now you can tweak the values to test the code a little bit more, but congratulations, you've done your first TypeScript project. If you enjoyed this lesson, feel free to subscribe to the newsletter, to add a star to the GitHub repo, and to subscribe to this YouTube channel.